Good morning, dual credit statistics. Can y'all believe that y'all made it to the last day of the first week of school already? Well, you have. And so I can't tell you how happy it made me. Like right before I recorded this video, I saw where y'all were all working on the assignment that was for section 1.1. Y'all almost all got into Google Classroom. Almost everyone accessed the assignment. So that just makes me even more ready to come back on Monday. Let me share my screen so then we can get started with today's. And so the first thing you'll see is this comic. Usually when y'all walk in, I'll have a comic up on the board. But since I'm not there, that's kind of hard to do. So we'll just start off with this comic. What's the secret to success as any TV pundit? The studies have shown, Ploy. What's that? Just say the studies have shown first that all of your talking points go unquestioned, no matter how stupid they may be. The trick, of course, is saying it without giggling. What happened to critical thinking? Studies have shown that's for losers. So just kind of poking the bear, if you will, at the news media and stuff. Okay, so there's our daily comic. The news article for the day, I kind of talk about that, is talking about how supermarkets actually have what they call zones of seduction. Like those end caps that have all the chips and the snacks and everything. They put that there because even if oh, all the healthy stuff is on the outside. Don't go down the aisles. Well, okay, fair enough. You walk down the outsides, I'll put all the good stuff on the end caps, so you're still getting stuff that's in the middle of the aisles, but they're just on the end cap, and they're even going to make it sound like they have a sale on them. But more so than that, the article talks about, it's just a short one pager, but it talks about ploys that supermarkets can do to get you to buy more stuff. And there's some places that have cameras. Basically, they're set up like an experimental store. So they have cameras watching everybody, and then in the back room, they have thought engineers, if you will, analyzing what people do. So when you're going down an aisle, if you start noticing that everybody's shopping cart is getting stuck going down that aisle, it may be that the floor is just rough there due to wear and tear, or who knows, maybe they did that on purpose to slow you down so then you buy more stuff. But anyways, that's kind of what this article is talking about, just the different ploys that the supermarkets use to get you to buy stuff, including what this one out, but including music. You'll probably notice that when you go to the grocery store, the music is always upbeat and happy. Because if you're happy, you're going to buy more stuff. If the music's all angry and sad or something like that, you're like, just get me out of here. I don't want to be in here. This isn't a pleasant place to be. So you're going to try to just go get your stuff, get out because you don't want to be there. But, anyways, there's our comic, there's our news article. And so before we get into the lesson today, we're going to actually do an activity. So hopefully the sub has passed this one out to you. It's called Harnessing the Power of Statistics. I kind of mentioned this yesterday to y'all that we were going to do a little bit of linguistics, statistical linguistics, on one of the Federalist papers. You'll probably remember, especially those of y'all that are seniors, you probably remember from U.S. history that the Federalist Papers are a series of 85 essays that supported the ratification of the Constitution. And they had various authors. Among them were Alexander Hamilton, James Madison, and John Jay. And 73 of those, they actually know who wrote them. There's only 12 that are kind of in dispute. But using linguistics, those 12 they're thinking were written by Madison, James Madison, possibly with some help from Alexander Hamilton. So one of the ways they could tell is by looking at the average word length of the papers that are not in dispute. So they would look at Alexander Hamilton's and take the length of all his words and get an average length. Then go look at all the papers written by James Madison, all the papers written by John Jay. Get their average word length for those papers, and then for the ones that they don't know, they can turn around and get the average word length and say, oh, well, this one's 5.9, so that that matches up to John Jay more closely. Okay, so here's what I want us to do. We need to read this. Well, you don't have to read it, but kind of skim it. And then I want you to pick 5 words from the passage, count the number of letters in each word, and then find the average word length. And we're going to, quote unquote, share it as a class and create a class dot plot. So let's see. I'm going to look through this and I'm going to pick, we're just wanting to pick any 5 words that you think would represent the average. I don't know. Constitution. So I'm just picking my 5 words. Okay, so there's my 5 that I picked. Now, what we're going to do is count the length of the words and get our average. So I'm going to call this my 5. And I'm going to get the average. How do you get the average? You add everything up and divide by how many you have. So let's take a minute to do that. And while I'm doing it, I'm not going to be talking, so just kind of giving y'all that heads up. Okay, so my average for the 5 words that I picked was 6.8. So take a minute. It says that we're going to do a dot plot as a class. Unfortunately, without me being there, we really can't do that. But somebody step up as a leader and maybe record the values that y'all got as a class, record the values, and see kind of what everybody's around. I know when I've done this activity in the past, it's kind of been all over the place because you think you're picking some good words, but then we're all scattered out all over. So, anyways, I'm going to kind of take a guess that if we were to do a dot plot, whoa, that looks terrible. Can't even draw a straight line now. Let's try this again. Okay, this will work. Our line would probably, our dots, I should say, would probably be kind of just all over the place. Would be not very tall, but kind of just scattered. Maybe you picked the same, maybe you didn't. That would be my guess. Now, here's what I want you to do. There are actually, in this paragraph, there are 130 words. So what we're going to do is we're going to get our calculator and pick 5 random words. And I'll show you how to do this on your calculator. So we haven't picked any words yet, unless you know what I'm about to do. But on our calculator, we're going to go to calculate and then hit, I'll try to go slow, that way y'all can see what I'm doing. You'll hit menu, statistics, let me make sure I'm going for the right one. Nope. So I remember where it's at. Where is it? Where did it go? Did I get to the right one? No, I didn't. Okay, sorry. Menu, probability, then down to random, and random integer. Now we have to tell it what random integer to put in. Like what? It's just gonna be, if we don't put anything, it's gonna just pick any random number. So the lowest integer we wanted to pick is 1. And then we're gonna put a comma. The comma is down there by the O. Down on the keyboard by the O. If you watch my screen, the comma will turn red if you're still looking for it. So now it's the red button. There's where your comma's at. And then the max number of words is 130. I don't want to go above 130. Okay, so it picked word number 123. So I'm going to go to my page. I'm going to use word 123. 123. Now I need 4 other words because remember, we want 5 words. Wait, y'all are saying that y'all got 123 as well? Or y'all all got the same thing? How is that random? If everyone's getting the same thing, how on earth is that random? So before we can even do this, we have to do what's called seed the calculator. Because by default, the calculator all has the same seed. It's not a calculator or a computer isn't really random. So we have to seed it. Here's how to seed your calculator. So that way you get all different answers and you're not just all getting the same thing. So go to menu, probability, random, and then seed. So menu, probability, random, and then seed. If your neighbor is having trouble, maybe lean over and help them. And you can type any number you want now where the cursor is. Like my classroom number is S205, so I'm just going to type 205. Now y'all type other numbers. Don't type 205 because then yours is going to match mine exactly. Maybe you type your phone number. Maybe you type the road you live on. Maybe you type your social security number. I actually wouldn't do that, but hey, you do you. But type whatever random number you want to put in there and then hit enter. And it's going to tell you done. So now there's two ways we could do the random integer. You could go through the menus again, or you could just hit the up arrow a couple of times until it highlights rand int 1, 130. Hit enter twice, and it'll pick a number. So now our numbers should be different. Like mine is 110. Yours is probably something else. That's okay. That's what we want. So I'm not going to use 123. I'm going to use 110. And I need 4 more words. So I'm just going to hit enter 4 times. Okay. So 60, 26, 25, 60, 6, 25. And then what was my last one? 101. Okay, so there's the 5 that I'm going to pick this time. Now, you have to have 5 to be fair. Like, you can't say, oh, well, I got 101 twice, so I'm just going to use it. No. You need 5 different words. So if it gave you the same word, like the same number, twice, then you got to draw an extra one to replace it. You want 5 different words. So now we're going to do the same process. We're going to get the average with these 5. I'm going to do that back on the front. I'm going to say random 5s. Okay. If you're wondering what I'm doing, I'm just adding up the word lengths. I'm getting my average word length based on the random 5 that the calculator picked. Okay. So for my random 5, I ended up getting 4.6 letters per word. Let's say 4.6 is right here. I'll put a dot there. But then they're going to kind of be. Now we're going to probably have more people getting the same value. So it might look something more like this now. Somebody's still probably going to get a big one. Someone's still going to get a little bitty one. But they're going to be more clustered together. Okay, so what the reason this happens is when we pick our random 5, we think we're being random. It's like, oh, pick words that you think represent the average word. Well, look at mine. My average was 6.8. I'm like, oh, I'll get a big one, a little one, some in between ones. Our human nature is that we're not random. We put thought into it. Unless you just close your eyes and just start moving your finger over it and like, oh, okay, I'm picking that one. Okay, do another. Oh, okay, I'm picking that one. Even then, you're not random because you're thinking about how you're moving your finger. We're not random individuals. We put thought into pretty much everything we do. Unless you're a guy, and then sometimes you go into your nothing box and you don't think about anything, and that drives a lot of the females crazy. It's like, how can guys think of nothing? But, anyways, I digress. On a calculator, it's a bit more random. Calculators aren't perfectly random, but they are way more random than we'll ever be. So, what we have here is our true average is actually around 4.9. That's the true average word length. So versus us doing it randomly to where the calculator does it randomly, we're now clustered, instead of being all spread out, we're now clustered around the true average. Now let's take this a step further. What's a way we could get possibly even closer to the true average? Well, we said it 2 days ago when we were doing the Parkinson's activity. We said we could get closer by increasing our sample size. So maybe now you do a random 20 words. This is going to take a while. So I'm going to do it. It's going to be the same process. I'm going to do it, but I'm not going to really talk through it because it is the same process. I will kind of say, okay, here's how I'm getting my numbers. Well, here's how I'm getting them. I'm going to clear this. Doc B. And then let me make sure it's the seed is still there. So menu, probability, random int. When I did doc B, I may have just cleared everything, including the seed. So I may need to reseed it. No, okay. Because I didn't get 54 the first time. So we're good. We seeded it. It's okay. So I'm just going to do this 20 times. Okay, I did it 20 times. Remember, you need 20 unique words. So if you get to the end and you're like, I've already circled that word, I've already highlighted that word for this set of 20, then you can't count it. What I would do is go through the list. Like I can already see I got two 54s. So I'm going to have to draw some extras at the end. But let's just see how many extras we'll really need. I'm going to go through now and start highlighting the ones that it told me. 54, 64, 54, 64. What else? 11, 33. Eleven, 33. 69, 70, 16. Okay. 69, 70, 16, 82, 84, and 41, 82, 84, and 40, 82, 84, 41. Okay. 86, 34, 24, 86. Okay. 86, 34, 24. Ninety-eight, 126. 98, 126. 126. 98. Okay. 70, 11. Already got 70. Already got 11. 43. 71. 43. Yeah, I don't have 43. I don't have 71. And then 54. I think I've got that one already. Yep. Okay, so I did the 20 and I went through and highlighted. Now let me see how many I actually highlighted. I need 20 words without repeating. So let's see how many I highlighted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so I only have 17 unique words that I picked, which means I need 3 more. 1, 2, 3. Okay, let's see if these work. 52. Okay, 52. 75. Now what's my last one? 47. There's 47. Okay, so there's my 20. I'm going to take the average of those, just like we've done with the 5. We'll take the average. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, yeah. Okay, so I got all my counts done. Now I just gotta add them all up and get the average. Okay, so this is gonna be 111. And I need to do 111 divided by 20. My average when I did the 20 words was 5.55. So I was actually further away from my personal sample. For some of y'all, this may be the closest y'all have been to the true average of 4.9. So we won't worry per se about plotting this one or trying to plot this one, but take a minute, talk to your neighbors, see what they got as their average. See if it's close to this 4.9, or if you're like me and you actually got further away. But anyways, that's the power of using linguistics. So evidently, in this case, since they traced it back to Madison, possibly with help from Hamilton, that means his average and Hamilton's average perhaps was close to 4.9. Now, this isn't the only metric they used. This is just one of the metrics. And obviously, they wouldn't be doing this by hand. They would like feed this into a computer, and the computer would crunch all the numbers for them. But, anyways, hopefully you enjoyed this. The one thing I want you to take away from this is the more random you are when sampling, the better your estimate for the average is going to be. I guess there's two things. And then two, overall, the larger your sample size, the better the average. So we want to be random with large samples. And that'll get us as close to the actual population average as we can. But anyways, there's our activity. You're like, my goodness, this is going on forever. The good news is the lesson today is pretty darn short as far as notes go. So let's get our notes packet out that you got yesterday. And we're going to look at section 1.2. Okay, section 1.2. Data classification. When you're looking at variables, what it means by data is like you want to classify your variables as qualitative or quantitative. Those are the two types. The qualitative data Qualitative data consists of attributes, labels, and non-numerical entries. They're not always non-numerical entries, but if it's non-numerical, you can bet your life savings it's going to be qualitative. There's no way I could turn red into a count. How many cars did you count? Red. No, how many? Red. It doesn't work like that. Qualitative is looking at attributes, labels, and non-numeric entries. Quantitative data consists of numbers that are measurements or counts. So how many cars did you count? 5. That's a quantitative, like, piece of quantitative data. Now, there's levels of measurement to data. And a lot of people have been doing acronyms. Like the first time I taught this lesson and people started doing acronyms, I'm like, I would have never thought of that. They use the acronym NOIR. Nominal, ordinal, interval, ratio. Nominal data can only be put into categories. So that's like your favorite ice cream. What color shirt you have on. It can only be put into categories. Like there's no that's all you can do with it. Like your favorite ice cream. Okay. Maybe it's got chocolate in it and it doesn't, or the categories could be the ice cream flavor themselves. But that's the extent you can do. So on nominal data, we're going to kind of jump all over this area. But on nominal data has no math computation. So I've already kind of given some examples. Ice cream flavor. Color of shirts. Maybe type of music. V genres. Like action or romance or whatever the case may be there. But then there's also some nominal data that is numeric, but you can't do math with it. What's a number that you can think of that it would not make sense? Like if you and your neighbor, let's just say, I'll just give you an example, phone number. Would it make any sense for you and your neighbor to subtract phone numbers? Or add phone numbers or multiply phone numbers? Would that tell you any information? No. So nominal data can also include phone numbers, maybe your social security number, part number like at a store, inventory number, that type of deal. Ordinal data can be put into categories, but then you can also arrange the data in order. So it has a sense of order to it. It's still no math computation. But at least you can put it in order. You can do something with it. An example of this would be like movie ratings. Thank you. What are your standard movie ratings? You got G, PG, PG-13, R, and we'll stop there. If you said triple X, shame on you. But anyways, movie ratings, we can put movies in order. We know that the G rating is safe for all audiences. Even your 1-year-old can watch it. The R rating, you have to be mature to watch it. If you're not, I think 18, 21, I can't remember if it's 18 or 21. You've got to actually get parental consent to go without your parents. Like, you would not show an R rated movie to a 1-year-old. At least I wouldn't. Maybe you would, but I wouldn't. But you can put them in order. The orders make sense. So the thing to remember here, for qualitative data, they are attributes or labels. Now we move to quantitative data. Quantitative data is often numerical measurements or counts. So for the interval level of measurement, you can put it in a category, you can arrange it in order, but then it makes sense to actually be able to subtract data entries. An example of this would be like IQ score. For interval data, IQ score would work. You can, if my IQ score was a 15 and yours was a 25, you could say your IQ is 10 points higher than mine. And that makes sense. You did 25 minus 15. That works. Average temperature, something like average temperature. If I said that the average temperature in July is 96 degrees and the average temperature in December is 66 degrees, that means that it's on average 30 degrees warmer in July than December. That makes sense. I can subtract the data entries. Now, ratio data. You may be thinking, oh, you can make a ratio of them. You can't. But really, what ratio data has is you can determine if one entry is a multiple of another. If I have 2 cookies and you have 6 cookies, you have 3 times the amount of cookies that I have. Yes, you can say, oh, well, I have 4 more. Yeah, you do, but you have 3 times as much. So ratio data can be put into categories. It can be arranged in order. You can subtract them, like you have 4 more cookies than I do. But you can also determine if one data entry is a multiple of another. Meaning if I had 2, you had 6, you have 3 times the amount that I have. I'm going to put that down here as a example. Number of cookies. Cookie Monster want cookies. Now, the big takeaway for ratio data is it has an inherent zero. As and inherent 0. An inherent 0 means that 0 equals none. So, like, if you said you have 0 cookies, that means you have no cookies. And you're going to be sad. You have no cookies. So sad. But ratio data has an inherent 0. That's why I couldn't say the average temperature was an example of ratio data. If I said the average temperature was 0, it's 0 degrees, does that mean I'm saying there is no temperature? Because remember, inherent 0 means when I say 0, it means none. So if I say it's 0 degrees, does that mean there's no temperature? No, that means I'm gonna start like putting on coats and jackets and everything else because it's freezing outside. So inherent 0 is specific to ratio data. If I said you had a 0 IQ score, does that mean you don't have a brain or scarecrow? No, that means your IQ is really low, and I'm sorry, but that doesn't mean you're non existent or you have no brain. So just remember that's the key difference between those two. Ratio data has that inherent 0 where 0 means none, nothing, 0, zip, nada. It does not exist. Interval data, 0 can still mean something. If the average temperature is 0, it means it's cold. I need to put on jackets. If your average IQ score is 0, I'm sorry. You got a brain, but I'll just leave it at that. But anyways, that's really all there is to today's lesson. The sub should give you your next assignment. It'll be posted in Google Classroom, just like yesterday's was. And yeah, hopefully this is the last you'll see me on video for a little bit because I hope to be back on Monday or be there for the first time. There's no back. I haven't been there yet. But I'll be with y'all hopefully on Monday. So for now, just remember that you are loved, you are created to do wonderful things, and you are awesome. Always believe.